Hello, hello, hi everyone. Let's get started first with that proof. So apparently, um, that little tidbit was partially incorrect in that it was supposed to be for odd powers greater than one. So, because the trick for the integral has almost nothing to do with that flow chart, and apparently people online were like, well, it's just the one that's given to you. And I'm like, whatever, fine. So if I do an integral of secant of theta, or let me write x, excuse me, with respect to x, then technically you can use a trick where you multiply and divide by 1, or by the same term, I mean. Secant theta plus tangent of theta over secant of theta, or I keep doing theta, of have x, plus tangent of x, and then you'll get secant squared of x plus secant of x tangent of x over secant of x plus tangent of x. And then you do use substitution because technically this guy's derivative appears right here. We know derivative of secant is secant squared of x. And derivative of tangent is secant. No, I said the other way. Tangent's derivative of secant. Secant's derivative of secant times tangent. So that means you're just left with 1 over u du. And then that's just going to be ln of u plus c. And then you plug in back u. A little kind of annoying in my opinion, because I also took what the textbook said at face value. But I can see where they also are just like, well, you use it to get, that's still true because I saw an example where they use secant to the third, and after doing integration by parts, they get the integral of secant, which just happens to be, this expression right here. So it's a bit annoying, but at the end of the day, we aren't going to be asking those sort of trick questions, and I'm the one making the test, so we don't have anything to worry about. All right, let's go ahead and do the first page. So just keep in mind, this is your group. Oh, this is your worksheet 3.2 and your worksheet 3.3. So keep that in mind. Okay, so let's play this game. It says match the expressions. Okay, secant squared minus 1. Well, that's just going to be tangent squared. 1 over sine is just cosecant sine of x times cosine of x. That's a double angle formula part that's really here, because technically it's secant of 2x is equal to 2 times sine cosine, but we have that already, so we're good. That's going to be cosine squared. That's going to be cosine. That's going to be 1. That's going to be sine. Sine. That's not sine. As secant. This is secant squared. And then these are both power reducing formulas. The one with the minus is sine squared. And then the one with the plus is cosine squared. Actually, for that, let me just double check because for the power reducing formulas, I do tend to forget them. So I just wanna double check. No whammies. That's the wrong piece of paper. And Yeah. Okay. Just double check it right here. Okay. All right. So let's start off with these ideas. First one is that we have sine to the third times cosine squared times dx. Now we have the part where it says sine, its power is odd. So we take out one of the signs. Sine squared of x, cosine squared of x, dx. And then we replace this with a term that has cosine. So we have sine x 1 minus cosine squared of x, and then cosine squared of x dx. And then you can go ahead and you can plug in the u now, or you can distribute. I'm just going to go ahead and plug in the u now. It says u needs to be cosine of x, and du will be negative sine of x dx. We see that the only thing that isn't included is the negative. So we're just going to extend it to be negative du is equal to sine x dx. So we have the integral of negative first of 1 minus u squared times u squared du, which is just u squared minus u4 to power 4 du, which is u3 over 3 minus u5 over 5 plus c. I'm going to plug in the u while also distributing the negative. You'll have a negative cosine to the power of 3 of x over 3. And then you'll have it adding cosine to the power of 5 of x over 5 plus c. That's going to be your answer. Next one. Cosine to the power of 4. And the step says if m and n are even, use power reduction identities until you can integrate directly. Okay, so here we just have the case where power reduction identities are going to help us with this one. So let's go ahead and rewrite this to where we can use the power reduction. So cosine squared dx, the power reduction is, oh my gosh, why am I blanking out on it? It is, I'm gonna just write it right here. There it is. It is, in parentheses, 1/2 of 1 plus cosine of 2x, all of which is squared, dx. And then you're going to go ahead and let the 2 escape, or the 1/2 escape to be 1 over 4. 1 plus cosine of 2x squared dx. Well, we know that's just going to be um a FOIL cosine squared of 2x plus 2 cosine of 2x and plus 1. And then you also may benefit from doing a power reduction formula from there as well. You'll have parentheses 1/2, another parentheses 1 plus cosine of 2 times 2x, which is 4x. I'm just making sure I wrote this correctly. and plus 2 cosine of 2x plus 1. Right. And then I need to rearrange these so they're all as separate as can be. Let's see. I'm gonna go ahead and already start off with saying that's 1/2. So 1/2 plus 1 is 3/2. And then we have 1/2 of cosine of 4x. 1/2 of cosine cox plus 2 cosine of 2x plus 3/2. Um, if you wanted to, you could factor out the 1/2. I don't know how helpful that will be though. If that makes the problem more legible for you, mm, you could definitely do it, but I'm not gonna hate on it if you don't. I'm gonna do it just because I think maybe it would be more helpful. 1/8 cosine of 4x plus, in this case, it'll be 4. So you factor out 1/2 of that, cosine of 2x, then plus 3. From here, you have the choice of doing your own substitution methods within these integrals, but I'm gonna choose. I'm gonna choose not to skip them. Actually, I changed my mind. So for here, you do. I'm gonna skip them a little bit. Actually, you to be 4x. So du is 4dx, and then in a similar way, this one you're going to pick u to be 2x, so du is 2dx. So in that case, you're left with a final step, 1/8 of sine of 4x over 4 plus 2 sine of 2x and then plus 3x and plus c. All right, I'm just quickly double checking that my answer matches, and it does. Okay, good. So that's going to be my answer. All right, last one, the 3.2, we have sine squared of x. That one is pretty straightforward. You just rewrite it with the power reducing formula. We have 1/2 of 1 minus cosine of 2x dx. And then you're going to use, for this one, you use the u substitution. And you should get, for this, you'll just get x. And for this, you'll get minus sine of 2x over 2 and plus c. All right, and that's pretty much it. Again, for all of these guys, just keep in mind that if you absolutely needed to, you could just do the derivative and you should be able to get back that first result. But I'm not going to worry too much about that technicality because I'm hoping that by now That's pretty ingrained in your mind. Right. Now we got to use those case ideas with these. Okay. Now these are harder version of the case ideas, but the idea is the same. If we see a square root with any one of those varying additions, subtractions of x, we have to use those provided substitutions. So let's start off with this one. This one is a case one idea. Here, I'm going to use different color. So let's go ahead and do that. Case one proposes that x substitution is using sine. So we know that it's 4, so it's going to be 2 sine of theta. We know that x squared will be 4 sine of theta, and dx will be 2 cosine of theta, d theta. All right. From here, we're going to plug everything in as much as possible. On the top, we will get 4 sine of theta dx. Let's make that an 8 then already. 8 cosine of theta. And then I'll put d theta on the side over square root of 4 minus 4 sine squared of x. Of theta, excuse me. Factor out the 4. It will escape as a 2, and 8 divided by 2 is 4. So 4 sine of theta cosine of theta over square root of 1 minus sine squared of theta. We know this will simplify to just a cosine of theta, which will cancel out. And you're left with the integral 4 sine of theta, which comes out to be negative 4 cosine of theta, then plus c. All right. Afterwards, though, you're not done because then we have to rewrite everything to be in terms. Well, I want to see. Oh, I made a mistake. The mistake I made was I forgot to square sine. So this was squared, 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 squared. And then that step's the only step that's wrong. Okay. So in that case, we would have to use a power reducing formula, which is the 1/2 escapes. 1 minus cosine of 2 theta d theta. And then we would simplify that to be 1 minus cosine of 2 theta. That integral, well, that just becomes what? Theta. And then this guy's integral becomes negative sine of 2 theta over 2. The only thing I am skipping is using the u substitution. So keep that in mind. Okay. I could technically simplify this step of this a step further by doing this, distributing the 2. And then afterwards I'll use the double angle identity to get 2 theta minus sine. Wait, yes, 1/2, right? Is it one? Yeah, because it's 1/2 over Let me just double check because I know it was even brought up here. Yes. Oh no, it's not. 'Cause look, one half's included. Okay, so I made the mistake. So it's just gonna be 2 sine theta cosine of theta and plus c plus c plus c. Okay. We need to figure out sine of theta and cosine of theta. We know sine of theta is just going to be x over 2, but we need the reference triangle to figure out what cosine is going to be. So opposite over hypotenuse, that means this will be 4 minus x squared. So we're left with 2 of sine inverse of x over 2 minus 2 times x over 2 for sine, and then for cosine, the square root of 4 minus x squared over 2 plus c. That really can't be simplified any further. This definitely can into just 1 over 2 because those 2's will cancel out. X square root 4 minus x squared and plus c. Alright, that's it. Okay, next we have the x squared being subtracted by somebody, so that's going to be a case 3 problem where x has to be the a times secant of theta, and the a in this case is a 3. So x squared is going to be 9 secant squared of theta, then dx is going to be 3 secant of theta tangent of theta. All right, let's plug in everything. On the top will be 3. Oh, forgot d theta. 3 secant of theta, tangent of theta, d theta. We have x squared on the side to be 9 secant squared of theta. And square root of 9 secant squared of theta minus 9. Okay, from here, I'm going to let all of the numbers escape to be 3 over 9 times 9 will escape as underscore root, so it'll be 3. So that'll probably cancel, and not probably, that does cancel out to be 1 over 9. And we can already mess with the secants a little bit, cancel that as well. And we're left with tangent of theta over secant of theta times the square root of secant squared of theta minus 1. That whole thing is going to be tangent. So 1 over 9, derivative, tangent of theta over secant of theta times tangent of theta. Because that'll be tangent squared, square rooted. We'll cancel it out. And then tangent on the top and the bottom cancel out. So we're left with 1 over 9. Integral 1 over secant of theta with respect to theta, which is just cosine. Which, furthermore, is just 1 over 9 sine of theta plus c. Then from here, we need to figure out what sine of theta is. Now, originally, we were told that secant of theta is x over 3, so x is the hypotenuse and 3 is the adjacent. So we know this is just x squared minus 3. And, oh, minus 3 squared, which is 9. And then we just plug that in for sine, because it's opposite over hypotenuse. So 1 over 9 square root of x squared minus 9 over x. and then plus c. And that's our answer. All right. Next one. We have two more. We have another subtraction one, which is going to be a case one. In case one, we used sine 25, so that means it's 5 sine of theta. That means that x squared will be 25 sine squared of theta, and dx will be 5 cosine of theta d theta. So we're going to go ahead and plug everything in. We got on the top 25 sine squared of theta, and then another 5, so 125 cosine of theta d theta. And on the bottom, we have 25 minus 25 sine squared of theta. The 25s escapes, and escapes under squared, so it becomes 5. So that just is 25 sine squared of theta cosine of theta over the square root of 1 minus sine squared of theta, which just becomes a cosine squared, which will become just a cosine after square root, and will cancel out. So we're left with 25 integral of sine squared of theta d theta. And afterwards, we will use a power reducing formula to get that sine squared to be 1 minus cosine of 2 theta d theta. Do those integrals respectively. We have 25 over 2 times, I'm sorry, not x theta. And then we have negative sine of 2 theta over 2. And then we'll use this to just plug in an expression that has nothing. If it's a trig, it has just trig functions of theta. So it'll be sine of theta cosine of theta d theta. No, not d theta, sorry, force habit. Plus c. And then we need to figure out, we technically already have sine, but we need to figure out cosine. Just doing the reference triangle, sine, opposite x. Actually, I think I've been skipping that step. So when I say it's x over 5, it's because I'm dividing by 5. And then it's opposite over hypotenuse. 25 minus x squared. And then we have now cosine. So let me just write this out. Theta is sine inverse of x over 5 minus sine, which is x over 5, and then cosine, which is the square root of 25 minus x squared over 5 plus c. From here, definitely could help a little bit to just distribute the 25, excuse me, but it doesn't help like a crazy amount. So I would consider this, well, after multiplying that and this to be the correct answer. Alright, last one. And we have a case 2 where they're just adding. So that means we use tangent. And for this one, it actually would just be tangent because A is 1. So that means x squared is just tangent squared, and dx is just secant squared of theta d theta. Okay. So on the top we have tangent of theta, secant squared of theta d theta over tangent squared of theta plus 1. So after that, that will become secant, and that will cancel out one of the secants. So you're left with the integral of tangent of theta times secant of theta. Well, we know from our derivatives, and that we do know, that this is just a derivative of secant. So we know it's going to be secant of theta plus c. The only thing left is to figure out what secant even is. So using the reference triangle, tangent is equal to x. So that's a opposite over adjacent. So it's x, and that'll be a 1. And then the hypotenuse, which we need for secant, is just x squared plus 1. Square rooted, I mean. And then secant is hypotenuse over adjacent, which really just simplified to square root of x squared plus 1 plus c. And that's our answer. All right, and that's going to wrap up the worksheet video, guys. Let me know if you have any questions. And I know I want to see in the other videos, I promised that today's videos would be horizontal and vertical, but something came up so where that wasn't the case anymore. But I'm pretty sure tomorrow's video will be horizontal and vertical. All right. See you on the next one. Bye bye.